I'm here at one of our factories in Lake City, Pennsylvania, where we manufacture compressed air and gas dryers. Water contamination is a major problem in many compressed air systems. At Vanair, we manufacture a wide range of technologies for removing moisture from compressed air systems. Today, we're going to take a close look at just one of these technologies, the single tower deliquescent dryer. This is a cutaway model of a single tower deliquescent dryer. All single tower deliquescent dryers consist of two main components, the vessel, and then inside the vessel, the desiccant. The process is very simple. Wet compressed air enters the inlet. Air flows up through the bed of desiccant. The desiccant acts like a sponge, absorbing water vapor or humidity from the compressed air. Then dry compressed air exits the top of the vessel. As the desiccant absorbs humidity, it deliquesces or dissolves, slowly forming a solution that drips to the bottom of the vessel. The solution is periodically drained from a drain valve. New desiccant is added several times per year. No moving parts, no electricity, extremely low pressure drop, very, very simple. I'm here in a small compressor shed. We've got a 10 horsepower reciprocating compressor. The compressed air is feeding pneumatic tools and cylinders in an adjacent manufacturing facility. The air needs to be clean and dry so that the tools and valves aren't damaged. The tank is pressurized and has been operating. We're at 100 pounds of pressure. Condensation has likely already formed within the tank. If we cracked the drain line valve behind me, we would see that some water is already condensed. Now, before sending the air to the shop, we want to run it through a single tower deliquescent dryer. So the flow pattern coming out of the compressor is very simple. Air leaves the compressor, enters the coalescing pre-filter. This filter removes any lubricating oil that's coming off of the compressor. Next, we flow into the dryer. Wet air flows up through the bed of dry-like desiccant tablets. Water vapor is removed. Dry air exits the top of the vessel. Very simple. No moving parts, no electricity required. Finally, dry air goes through a particulate after filter. Now, the particulate after filter is going to remove any dust, any fines, any pipe scale. Finally, dry, clean air leaves our air treatment system and goes to the plant. Notice how we've piped the system. We've put block and bypass valves around each of the vessels, both filters and the dryer. Having block and bypass valves allows us to isolate any of the vessels for easy service. Another point, we have automatic drains on the dryer and on the pre-filter. These drains allow continuous removal of liquids from the vessels. Before starting up the dryer, we're going to fill the vessel with Dryalite desiccant. I've just filled the dryer with Dryalite desiccant. Now I'm going to close the fill hatch and tighten it down before pressurizing the dryer vessel. Now that I've closed up the dryer, I'm ready to open the valve on the discharge of the compressor and pressurize the system. Next, I'm going to slowly pressurize the dryer vessel. Okay, we've pressurized the system and the dryer is in operation. We're sending clean, dry, compressed air to our shop, and no condensation is going to form. The maintenance on a single tower deliquescent dryer is very simple. Once every 8-hour shift, we're going to make sure that the drain operates. Every 2 or 3 months, we're going to add new Dry-A-Lite desiccant. That's it. Very simple. We've got our single tower dryer plumbed in, installed, and operating. Now we're going to check its performance. A common measure of compressed air dryer performance is called dew point. To measure the dew point before the dryer, we've installed a sample line and attached it to a dew point meter. Our dew point meter is showing that the dew point of the compressed air going into the dryer is 42 degrees on this cool spring day. We've now moved the sample line for our dew point meter to a port after the compressed air dryer. Let's take a look at what the dew point is after the compressed air has been dried. The dew point meter is showing us that the dried compressed air now has a dew point of about 22 to 24 degrees. So we've achieved a dew point suppression of about 20 degrees Fahrenheit.